Now look carefully. These are the things that we remember whenever we are doing any question of definite integral. So for definite integral, just integrate and then put upper limit minus lower limit. Upper limit minus lower limit. That's the thing that we do for definite integral. Just two more points. Whenever we are doing any question of definite integral by the substitution method. Whenever we are doing any question of definite integral by the substitution method, we always change the limits. हमेशा limit change करें. Last point, whenever we are doing any question of definite integral by using integration by parts. अगर हम integration by parts वाला method use करें, never use limits with internal integral. That's the only thing, that's the only concept for the first exercise. That is for simple questions, just integrate, put up the limits. Whenever substitution is required, change the limits. Whenever that is whenever you're doing the question by using integration by parts, never use a limit with the internal integral. और इन तीनों को मैं अभी example wise और समझा रहा हूँ. I hope it's a quick recap. X square plus 1 we have taken as t, differential adjust किया, values put up की. यहाँ पर हम 0 to 1 इसलिए नहीं लिख रहे हैं because this is completely in terms of t और 0 और 1 x की values है. If these are the values of x, we can put it in t, we'll get the corresponding values of t. When x is equal to 0, t will be equal to 0 plus 1. When x is equal to 1, t will be equal to 2. So in place of 0 to 1, it will now be 1 to 2. Am I clear with that? 50% definite integral clear है अगर आपको ये clear है. I can. Limits for 0 to 1. ये x की values थी. जब x 0 है तो t की value 1. जब x की value 1 है तो t की value 1 square plus 1, that is 2. So in place of 0 to 1, we are writing 1 to 2. So this is exactly what I meant by changing the limits. So whenever we are doing any question of definite integral by the substitution method, we always change the limits. Am I clear with it? कहीं शादी में जाना है? Rajat, what will be the integral of 1 upon t? Log t. And then, अच्छा यहाँ पर क्योंकि numbers involved होंगे, so never forget to use mod. Within the limit 1 to 2. दिया बेटे apply करो आप जरा limit यहाँ पर, बताओ क्या आएगा? Log 2 minus log. It is log 2 minus log 1. पूरे expression में पहले upper limit minus फिर उसी expression में lower limit. Franjli, what's the value of log 1? 0. So this will be 1 upon 2 log 2. Right? आप यहाँ छोड़ सकते हो, कोई प्रॉब्लम नहीं है, पूरे मार्क्स बनेंगे. Still, if you're not satisfied, या फिर proving का क्वेश्चन है. Can we write this as log 2 to the power half? 1 upon 2 log 2. To the power half means root. So log root 2. That is completely all. Is it clear? Any doubts? Please note it down. Question. वी आर नॉट यूजिंग बाय पार्ट्स, क्योंकि जस्ट बाय चांस अगर हमने स्टार्ट भी कर दिया होता बाय पार्ट्स इसमें, तो जब हम इंटीग्रेट करते हैं e to the power sin x, तो वहां प्रॉब्लम आती है. तो बेस्ट वे ऑफ डूइंग दिस क्वेश्चन इज to first of all take, or we can take complete e to the power sin x also as t. मैं खाली sin x को ले रहा था, that is also correct. Now differential of this will be e to the power sin x into cos x of whole dx is equal to dt. पूरा का पूरा adjust हो गया. We are using substitution method, so we'll have to change the limits. When x is equal to 0, t will be equal to e to the power sin 0. Sin 0 is 0, so this will be equal to 1. यहाँ पर पुट अप करेंगे ना, जब x की वैल्यू 0, यहाँ पुट अप कर दीजिए इसमें. When x is equal to pi upon 2, this will be e raised to the power sin pi upon 2. Sin 90 degrees is 1, so e to the power 1, that is e. So now in place of 0 to pi by 2, it will actually be 1 to e. Cos x dx will be equal to, this complete in fact will be equal to dt only. बाकी कुछ बचा ही नहीं है. What is the integral of dt? T. T within limit 1 to e. So this will be e minus 1. That's the answer. So correct start अगर आपने किया है तो it will be very very easy. Question number 8. Integral 0 to 2. बहुत, that is ये एक golden opportunity है आपके पास integration revise करने की. Most of the question you, मैं करूँगा, ठीक है, तो ये तो x जैसा बन, मतलब 2 जैसा बन गया. Most of these questions you have already done. Recall होना चाहिए देखते हैं. वहां कुछ नहीं लिखा. हाँ जी बेटे, बाहर भी सेम एक्सप्रेशन फॉर्म करेंगे, और वो कैसे कर सकते हैं? +2 and -2. 0 to 2 x +2 -2 root of x +2 dx. If you multiply this inside x the power, so sorry, अभी ठीक है देखो.
No, it's fine, sir.
So this will be x +2 to the power 3 by 2 dx minus 2 outside 0 to 2 x +2 to the power half dx. Am I clear with it? Am I clear with it? Now simple integral. This will be x +2 to the power 5 by 2, 2 by 5 with the limit 0 to 2. Minus 2 x +2 to the power 3 by 2 into 2 by 3 with the limit 0, right? So this will be 2 by 5. पहले 2 put up कर देते हैं. 4 to the power 5 by 2 minus 0. 4 by 3, 4 to the power 3 by 2 minus 0. 4 to the power 5 by 2. 5 by 2 means 2.5. So 4 to the power 2 into 4 to the power half. एक मिनट, एक गड़बड़ की है मैंने. I have not put up the limits properly. Look, 2 by 5. जब हम 2 put up करेंगे तो 4 to the power 5 by 2. जब हम 0 put up करेंगे, this 2 shall also remain. So this should be 2 raised to the power 5 by 2. Minus 4 by 3, and this will be 4 to the power 3 by 2 minus 2 to the power 3 by 2. Right? 2 by 5, 4 to the power 5 by 2 will be 2 raised to the power 2 into 5 by 2. और यहां पर इसको लिख सकते हैं 2 raised to the power 2.5 minus 4 by 3, 2 raised to the power 2 into 3 by 2, और minus 2 raised to the power 1.5. Got this? ध्यान नहीं आपको यहाँ पे. So now this will be 2 by 5. This 2 and this 2 cancelled, this 2 and this 2 cancelled. 2 raised to the power 5, 64, 32. So this will be 32. 2 raised to the power 2.5. That means 2 raised to the power 2 into 2 raised to the power half. 2 raised to the power 2 will be 4. So 4 root 2 minus 4 by 3. 2 raised to the power 3, that is 8. 2 raised to the power 1.5. 2 root 2. So now this will be 64 upon 5 minus 32 upon 3 minus 8 upon 5 root 2 and plus 8 upon 3 root 2. So LCM will be 15, 5 3s are 64, 3s are 3 4s are 12, 3 6s are 18, minus 3 5s are 32, 5s are 160, plus LCM is again 15, 5 3s are minus 24 root 2, plus 3 5s are 40 root 2. So this will be 192 minus 160, 32 upon 15 and plus 8 root 2 upon 15. That's the answer. I hope it's clear. Before you start noting it down, just look at it, check all the steps carefully. Then only after that you start noting it down. If any step I need to make clear again, I'll explain. कौन सा वाला? Power वाला. Okay, to the power 5 by 2x. 4 can be written as 2 square. 2 cancel, 2 to the power 5. 2 raised to the power 5 upon 2 means 2 raised to the power 2.5. So 2 raised to the power 2, वो तो 4 हो गया. और 2 raised to the power half, that is root 2. So 4 root 2. ऐसे second expression. कौन सा वाला बेटे? 5 3s are and 3 8s are 24. 60. So sorry. This one. Thank you, Rajat. यहाँ पर पहले 2 पुट अप किया तो 4 raised to the power 5 by 2. जब 0 पुट अप किया तो 2 raised to the power 5 by 2. 2 plus 2 4 होता है ना, ऐसे कर सकते हैं काउंट. हाँ जी. नहीं. A piece of paper cannot decide your future. ये कह रहे थे ना आप उसमें. Somebody said integral 1 to 3 log x dx. We can write it as into 1. Now 1 will be taken as the second function, log x as second function. Now understand this. Whenever we are doing any question of definite integral by the method of integration by parts, we never use limits with the internal integral. Now what is the internal? There are actually two things to be understood. देखो by parts use करेंगे तो log x integral dx minus whole integral 1 to 3 d by dx of log x into integral of dx of whole dx. This is exactly what I meant when I said that we do not use limits with the internal integral. क्योंकि यहाँ पर अगर हमने लिमिट यूज करी तो फिर इसका आंसर तो हमेशा फिक्स्ड ही रहेगा, कांस्टेंट हो जाएगा. तो दिस इज द रीजन वी डू नॉट यूज लिमिट विद द इंटरनल इंटीग्रल. आप समझ रहे हैं? Now, second thing to be understood, log x integral dx will be x. So x we will write here, right? Without हाँ लिमिट सब पुट अप करेंगे, और जब हम लिमिट पुट अप करेंगे इट विल नॉट बी ओनली विद x, इट विल क्योंकि इनिशियली तो log x भी अंदर था, तो ये थोड़ी कि अब log x में लिमिट नहीं अप्लाई कर. Am I clear with it? तो यहाँ लिमिट यूज नहीं करनी और यहाँ लिमिट यूज करनी है, दोनों चीजें हमें पता होनी चाहिए. माइनस 1 2 3 dy dx ऑफ log x. कहीं जाना है बेटे प्रैक्टिस में? जागरण में कहीं? इंटीग्रल dx is x of whole dx. Clear? These two cancel. यहाँ पर लिमिट अप्लाई करेंगे पहले पूरे प्रोडक्ट में अपर लिमिट. So this will be 3 log 3 minus 1 log 1. So only 1. Minus integral of this will be x with the limit 1 to 3. Log 1 is 3 log 3 minus 3 minus. 3 log 3 minus 2. That's the answer. Is it difficult? So what are the two things that we have understood with help